Okay, thank you. Restart, rewind. Okay, welcome to the stream, everyone. Suds, I was just thanking you for following despite our technical issues, so it's kind of ironic that you couldn't hear me say that due to even more technical issues. The stream was a bit late starting because I couldn't figure out why my webcam wasn't working. The answer is that it was not plugged in. Hopefully you can see me and hear me now, and we're all good to go. I'm sure watching me play this game in silence was pretty riveting. Yeah, but we're working on this game, which is a clone of either Scorched Earth or Tank, depending on where in the world you're from and what you call it. Okay, awesome. Awesome, good to hear. Everything is running smoothly now. This is a professional operation, I'll have you know. Yeah, so last week we made this little game here, and the idea is that by using the arrow keys I can control the turret. I'm moving the red tank, or the turret of the red tank right now. And then by holding space, the longer I hold it for, the more powerful my shot will be, and I'm trying to account for this wind and try and land it on my opponent, the pink tank up the top there. Oh yeah, come on. Pretty pleased with myself. I would say that was first try, but this is like my third time trying to start the stream, so probably doesn't count. Yeah, so then the turn alternates and we kind of just go back and forth. That's where it's at now. So what I'm going to do, as we kind of traditionally do for any stream where, you know, we work on a project over more than 1 week, I'm just going to go all the way through the code and clean up and comment and maybe reorganize and tidy things up a bit. And as I'm doing that, hopefully explain to anyone who didn't tune in last time how everything fits together. So we have a few components to this here. The first one is this terrain, and this terrain is generated by Perlin noise. Probably won't go into too much detail, but basically Perlin noise allows us to create this natural kind of hills and valleys and mountains type effect. And the terrain is actually just stored as like a bitmap image, so it really is just stored as an image with pixels, which is often the most convenient way to do things if you want to have dynamic destruction and stuff blowing up and so on. Then we have our little tanks, so these are just little objects. We track the angle which they're aiming at. There's a bit of UI state stuff to handle us holding these keys down, and then we just have some simple physics where wind and gravity are applied to this projectile. And then it will kind of impact the ground and cause this explosion. So let's get straight into the code and try and walk through and tidy some of this up. So we have some just general constants. I'm going to maybe tidy these up slightly. So we have some like physics related stuff. Let's call these physics and gameplay constants. So we have gravity, we have wind speed. It's also kind of a gameplay thing. Let's also organize some of these out, which are more to do with how stuff looks. I should just call these kind of visual constants. So the whole screen has a scale factor, which is what gives us the nice chunky pixel look. We also have a certain color for the air, which is just transparent, and the terrain, which is a kind of middle kind of green color. How long did it take you to put together? So we did this on last week's stream, which was about 2.5 hours. Yeah, so I think that, yeah, 2.5 hours, like I can say pretty accurately. Then we have some UI stuff. And the only thing we really track is how long the... Awesome, yeah, thanks so much for tuning. I'm interested to know how people find this. I mean, there's a few places I post these, but yeah. Sudsp. How did you come across our little stream here? Oh, awesome, yeah. Coding Train is amazing, and Dan Schiffman is amazing, and processing is awesome, so I'm a huge fan of that whole thing. Okay, so those are some general sort of constants the game uses. We then have the kind of game state. So the way it works is the first state is the aiming state, and this is when you're controlling the position of the turret. Then you have the power state, which this is when you hold down space, you're kind of controlling the power of the shot. And then what I call the resolve state is just when the bullets are in the air and the explosions are happening, and the player no longer has control of the game while that's happening. We're just waiting for stuff to resolve, if you like. So there's some visual stuff. We have a tank class, which maybe we can look into now. So there are some constants here. I'm going to rename these to be a bit more clear. This just controls the angle at which the turret can point. And we're basically going from so if we have our kind of axis like this, then we only want our turret to be able to point kind of upwards. So we sort of limit it to like a range like this. So this is the kind of valid range of where your turret's allowed to point, which is controlled by these variables. Yeah. So I guess this is 0. This would be 0 degrees, and this would be pi degrees, or minus pi. So what I do is I want this little gap. I don't want it to be aimed like straight forwards. So this is like 0.1 pi, if you like. This is very arbitrary. It just sort of felt right. And this is from 0.1 pi up to 0.9 pi. So it gives you like almost 180 degrees, but not quite. Yeah. Yeah, that constant looks kind of cryptic. That's what that is. Then we have the length of the turret, obviously. So when we create a tank, we give it a certain position and color. I thought, yeah, right? Like, I actually got messed up and had the turrets pointing downwards in the previous stream, because to me, if I remember my math correctly, like, this is 0, and then this is like pi by 2. It should go like positive that way, but I guess because processing has y going downwards, you know, the origin's like in the top left of the screen, that it also kind of flips the way angles work. I guess that's what it is, yeah. But my initial instinct was that this should be 0, and it should increase like anti-clockwise. But apparently not. Okay. So we have this function on the tank, which will aim the turret. I'm going to rename this to turn the turret, because that's really kind of more like what it is. And there's another bit of code down here somewhere. Where is it? Okay, so the only thing is processing doesn't, as far as I know, give you a direct way of saying right now is this key being held down or not. So we have this bit of boilerplate code to keep track of which keys are being held, which I'll kind of label. So we listen for these kind of key pressed and key released events, and when a key's pressed, we add it to this set of currently held keys, and when it's released, we remove it from that set. There's also some special case code here to do with a spacebar launching the projectile, which we'll kind of get to in a minute. So we have a bit of logic which basically says, where are we? Yeah. So if we're in the aiming state, then we're going to pull out the active tank. It's kind of designed to be flexible, so we can have many tanks on the battlefield. Right now there's only 2, but you know, that's how it works. And then we basically call this function, which I've now renamed turn turret, just based on if right or left is held. The other thing is we have a kind of default aim rate, but if the shift key is held, then that gets reduced. I should probably make these constant as well. Let's call this fast turret turn rate, which was 0.5, and the slow was 0.1, I believe. Now we can make this a little bit more obvious what these numbers mean. So if you're holding shift, then our aim rate is going to be, okay, let's call it turn rate again to be a bit more consistent. It's either going to be the slow rate or the fast turn rate. Okay, hopefully that's relatively clear. I'm kind of jumping around a bit. Like if something doesn't make sense or is not clear, then please let me know and I'll go into detail on whatever But I'm just going to try and sort of follow the flow of the code as the game, kind of corresponding to how the gameplay works, and see if this makes sense. Okay. So at a certain point, we detect that the space key is pressed. So if we're in the aiming state and the space key is pressed, we're now going to transition to the power state. Oh, that's weird. And we're going to zero out the launch power. And then what happens is in the update, the launch power just incrementally increases. So it goes from 0 to 1, and the amount of time it takes to fill up is equal to this. So if this is 10 seconds, then, if 1 second has passed this frame, then it's going to go up by 1/10. So the bar fills up in this amount of time, which is kind of a convenient way for us to think about this, I think. Rather than like having a rate, to just say outright, how long do we want it to take? Because that's really what we, as a designer, that's probably what we care about more. And then we auto launch if the power fills up. So there are different ways these bars work in different games, right? Like sometimes you hold it down and it'll oscillate between like low and high power. But the way we've done it, if you hold it, it just, if you hold it too long, it just fires off at full power. Andy, thanks so much for the follow. Much, much appreciated. When launch projectile is called, what we do is we spawn a new projectile. So we ask the tank to launch a projectile. And we tell it how fast to launch it. Basically, that's what this parameter is. So we have a max launch speed and a launch power, which is a ratio between 0 and 1. Then when we launch it, we do a little bit of trig to figure out, where exactly the bullet should spawn and the initial velocity it should have. So we have our little tank like this, and it has a turret, which is like, let's say it's like this. Oh. Sorry, I don't have my tablet plugged in today. Not that that makes my drawings any better, but so in this case we kind of want to spawn the bullet here, like right at the tip, and we want to have this kind of vector, right? So what we do is we know the sort of central position of the tank. We know the angle of this turret, so we use vector from angle to get a unit vector that points basically in the direction of this, that's like 1 unit long. And then we just multiply that by the length of the turret. So we're basically taking the position of the tank and adding the length of the turret in the direction of the turret, which effectively starts at this point and steps along by the length of the turret, which gives us this endpoint here. We also use that same direction vector to give the... Yeah, just for the initial launch, exactly. So a projectile gets spawned with a position, a velocity, and we also give it a color. So the position is the tip of the turret, the velocity is whatever direction the turret is facing, but scaled by the launch speed that we want. And then that creates this projectile object. Yeah, exactly. So we actually have a class for the projectile which handles this stuff. So ultimately, it gets set into this active projectile variable, and our state changes to the resolve state, and then back in our main update function, if we're in the resolving state, then we're going to update this projectile. If there are explosions active, which we'll get to shortly, the projectile is then responsible for creating explosions. Then we'll update those. And if the projectile is dead, again, we'll talk about how a projectile determines when it's dead, and there's no active explosion, or the active explosion is dead, it means everything's kind of finished and done resolving. And then we will sort of generate a new random wind direction. That's another thing we never really touched on. So we pick a random direction and then we scale it by a random speed up to the maximum speed. Yeah, so the way the turns kind of work, actually we can see here at the end of resolve, we do this. So I'm going to say it's actually kind of not the cleanest way of doing things. So let me just, so that's kind of clean up. And then this, if you like, is, yeah, pick a new wind direction. So we keep track of the active tank, basically. And what this does is it causes it to start at 0. We have 2 tanks start at 0 index, go to index 1, and then the modulus wraps it back around. So it goes 0, 1, 0, 1, 0, 1. But if we had, if we had multiple tanks, this would just cycle through all of them. So it's fairly kind of generic, but hopefully it does what we want. Yeah, then I guess we have the projectile. How does this work? So a projectile has a position, a velocity, a color, and this little flag which tracks whether it's dead or not. So in the update function, if it's dead, we just bail out. We shouldn't really be updating this if it's dead, and I don't think we do, but you know, just for the sake of safety or being paranoid, we kind of do that. And then we apply the physics. So this is very, very standard kind of physics calculation where we apply the gravity to the velocity, we apply the wind to the velocity. Gravity is just a constant at the start of the program, which kind of generally points downwards. Wind is this variable which gets changed by our change wind function. And then we update the position based on that velocity. So this is a pretty standard like acceleration velocity position stack, you know, where the acceleration affects the velocity and then the velocity in turn affects the position. So I feel like, you know, 8 out of 10 streams we've done, we've implemented this kind of little simple physics in some form or another. Then we detect if we've collided with the terrain. What we do is we first find our position to the nearest pixel, because even though we track the position of the projectiles with vectors and floats, the actual world is on a grid. So we need to find the nearest kind of pixel, so we can... Basically what we're going to do is we're going to actually look into the texture which contains the background terrain and just check if the pixel's colored green or not. So super simple, not the most efficient, but it definitely works, and there's only one projectile. It's only like 1 pixel we're checking each time, so not really a big issue. If we're way out of bounds to the left, right, or bottom, then we just sort of mark the projectile as dead. It's gone out of bounds. If it goes off the top, then we don't kill the projectile, but we do bail out. I'll actually update this comment. We do sort of bail out and don't do the collision check with the terrain because we're not on screen, which means that we're not over the region of the texture of the background, right? So if you try to check if our projectile was off the top and we try to read into this texture, we'd get some out of bounds error or something, so we just bail out there. So we're allowed to exist off the top of the screen, but we're just not allowed to... They will. So right now there's only ever 1 projectile active at a time. So they get flagged as dead, and then the main game code sort of checks that here, and ultimately then like nulls it out. Yeah, if there were many projectiles, then we'd do something more fancy. And again, in other streams we've done stuff like that, where you have like a list of projectiles or some more fancy like pool of projectiles which get recycled and reused. But for now, we just keep track of 1 at any given time. And we check the main code kind of... This is how it informs the kind of main sketch code that it's done with, and it can be cleaned up, basically. So if we get to this point, we know that we're within the bounds of the screen, so we read into the terrain at a certain pixel, you know, the pixel where we are, rounded off. And if the pixel is green, or if it's whatever we set as the terrain color, then we determine that we have... Hey Ralio, thanks so much for the follow. Very, very much appreciated. Yeah, so we know that we've hit a solid pixel in the terrain. So that's what that is. Then what we do is you spawn an explosion. I don't really super like the way this is done, because this is just like a global variable up here. So I really don't like that we've done this. I would prefer a nicer like way to couple the projectile and have it spawn things back up into the world, but Since the game's so simple and there's only one projectile, I kind of allowed myself to do this, even though it's not the cleanest sort of architecture. This is the radius of the explosion, so let me actually, again, make that a constant. Was 20. Looks like it's probably an integer. No, okay, it's a float. You know, if we go on to implement different ammo types, then maybe this will be factored out in another way. But right now, each projectile, you know, spawns an explosion of the same size always. Yeah, so that spawns this explosion and it marks itself as dead. These load pixels and update pixels are just needed in processing if you're going to access the raw pixels of an image. It's just kind of how it works. Code for drawing a projectile is very simple. It's literally just a point. So let's talk about explosions, I guess. Explosion has a position and a radius. This is more like okay. This makes more sense to me, right? I'm kind of separating the parameters from the runtime state. Yeah, terrain texture is actually an image. We could have used just an array of booleans or bytes or something more fancy, but we are... Okay, so we're literally... I never talked about terrain. Okay, let's go back to terrain generation. Okay, I've not done this in the most in the most sensible order. The way we generate the terrain is that we create a P image, basically, with a certain width and height, and then we go through left to right, column by column, and we pick a height based on some Perlin noise. And then we, you know, fill in the terrain up to the height. So effectively we have our screen. And, you know, for the first column, we go through and ask Perlin noise to give us a random height. So maybe it gives us like that value. And then we just literally fill in all the pixels up to there, sort of one by one. And then all the pixels above get filled with like the color of the air. And then this is kind of how our terrain's drawn. Yeah, it's great. So you can do that with, yeah, create image will create a blank texture. So you give it a width and a height, and then you can use load pixels and update pixels and just setting the pixels, which I guess this does. So yeah, to fill in these sort of air pixels, we just iterate from the 0 coordinate down to this point, filling in with the color of the air, which is just transparent in this case, and then we fill the other ones with the ground color. You know, then we'll go to the next point. Maybe it generates a value like here, and then we'll go and we'll fill in the air above it, and then we'll fill in the ground sort of below it. And by drawing these strips, we ultimately form this kind of pixely terrain. So that's how that's generated. Yeah, so when we're doing our collisions, we just read those same pixels back and see if they're filled in with the terrain color. It's pretty nice. It's it's kind of like a, you know, yeah, pixels or voxel terrain is really convenient for this kind of thing. Yeah, so the explosion. So the explosion plays out over a certain period of time. It starts off, you know, you give it a position and a radius. But what it does is it starts small and then kind of grows until it fills that space. Then when it's kind of covered that its entire span, it will cut out a hole in the terrain behind it. You can't see the hole at that point because the explosion's still like visually on top, but then it will shrink its size back down again until it finally gets back down, and then you can see the hole it's left. So if we actually boot the game up, you should be able to see this a little bit more clearly. I could even have done like a slow-mo thing, but hopefully this makes sense. So you'll see it expand and then contract, leaving a hole behind it. And the way this works is it has a certain duration, and then every time we update, we just keep track of how long this explosion's been alive for. If it's been alive longer than its whole duration, we kind of mark it as dead. So when we draw it, we basically... Okay, here's how we actually draw it. So we know what its progress is between 0 and 1. We use a sine wave to determine the size of it. Yeah, right. It also, because we use a sine wave, so we use a sine which has like this shape naturally, right? So we map this to kind of the radius of the circle. So it starts at 0, kind of smoothly ramps up and then comes back down again. And that happens to animate quite nicely the size of this thing. So, you know, as our animation progress goes from 0 to 1 over time, we use sine, again, scaled by pi, because this point happens to be pi on, you know, that's the kind of scale we need. So when it's like halfway through, it's at peak size, and then it comes all the way back down. Yeah, we destroy that radius, and when it first crosses the halfway point, meaning when it's, you know, we don't know, given the frame rate and stuff, that it will land exactly on the midway point, right? It may be that as it's drawing frames, it draws a frame when it's this size, then this size, then this size, and then kind of this size, and it's like skipped over the exact midpoint. So what we do is we have this other little variable called isTriggered, and the first time we are past the halfway point and we haven't yet triggered, that's when we do that carving out, and then we set isTriggered to true, so, you know, on the subsequent frames it won't like recarve the hole in the terrain, which would just be kind of wasteful. The way the actual terrain carving works is we look at where the explosion landed. I draw it again, and we just kind of iterate through. So we find like the left hand, top, bottom and right of this circle. Yeah, or the first frame where it's past the halfway point. Because it may not land exactly on it depending on the timing, right, and the frame rate and stuff. So it will only trigger the carving once. It may happen to land exactly on the halfway point, or it may be like 0.6, and that's when it will do it, yeah. So we find the bounds of this, and that gives us a box, and we can just iterate, you know, 4x from here to here, and 4y from here to here. We can kind of iterate over the square, which contains our explosion, which is what this does. We sort of find, given the radius and the position, we find the bounds of it. There's also a bit here to account for making sure we don't, you know, if this explosion happens to be right on the edge of the screen and this is like off the side of the window, we don't check those pixels. So we iterate over the box containing the terrain. Actually, let me actually say that. It's actually a square. And then we right, so the box is like a first pass. We know that any pixel we need to carve out must be within the box, but then we still need to check, you know, this pixel's within the box, but it's not within the explosion, so we check every pixel's distance from the kind of center to determine whether we're gonna kind of carve out that pixel or not. So we just go through all the pixels and do that. And then when we carve out pixels, we just set its color to the transparent air color. Yeah, and that effectively does that for us. So I think we've covered most of the things there. One thing we haven't covered is these sort of wind particles, which I really don't like the way that I've done them. I tried to be a bit fancy and I think it was probably unnecessary. So the way these particles work, I think that's the last thing for us to cover. Yeah. Kind of covers most things there. Still not the most organized code. Yeah, right. I mean, it makes sense when you think about it, but yeah, I guess there's not a nicer way, right? Well, I guess what I could have done probably is used processing's drawing ability to draw a circle into that image, if that makes sense. Like, there's probably a way to do it that way actually, and use the ellipse function to actually draw a circle. This is basically like a filled circle drawing algorithm, right? Yeah, I probably could have done it that way, but I don't have a good reason why I didn't think of it. Maybe I should have done. But that's how that works. So the way the wind works is we have this little particle system. When it starts up, we spawn in. There's like, it always has a fixed number of... Yeah, like you probably have to filter... So terrain texture is just a P image. We'd have had to use like a P graphics, right? If you want to... Is that what you're getting at, Padgasho? So it's just a P image. There's this thing called a P graphics, which is like an image. Like in processing, I can call like rect or ellipse, you know, just like wherever. If I have a P image, then I can call, you know, my image dot rect to like draw into that specific image. So I'd have maybe had to use something like that. That's a pretty neat feature as well. If you've never looked into P graphics, you can do some fancy stuff with it, like where you want to draw a texture and then put that within a larger scene at the same time. It's really useful for that. So all we do for these particles is we just update each particle each frame and draw each particle each frame, and all the particles do is if they ever go out the bounds of the world, they respawn themselves. And they're kind of accelerated by the wind, but I think I maybe want to change how this works, because it doesn't look quite right. Yeah. Especially if the wind gets low, then they'll sort of continue coasting according to what the old wind was like. Like you kind of see them going upwards. Like you'll see the slow ones like gradually getting accelerated, and they'll get faster and faster. And if I'm just going to shoot the ground to cause the wind to change, you'll sort of see them slowly start to like shift over, but it's really got that confusing for the player. So I think the first actual real code tweak I want to do here is have them just a bit more rigidly follow. Yeah, I'm just going to have them like more rigidly follow the wind, I think. And then I can do something like... Actually, that might look somewhat okay by itself. I think the transition's still going to be kind of weird. Yeah, like when they fly off the top, they then spawn back. Oh, that's almost making me dizzy. Okay. So what I think is I'm just going to do something like... Okay, what I could do... So right now each wind particle has a certain velocity. That V, and then the wind, there's a certain wind velocity, like let's say that's W. So, and the wind, each frame is going to like slightly shift the velocity until eventually it kind of ends up aligning with the wind. But what I may just do instead is just say something like every frame I'm going to set the velocity to the midpoint between the current velocity and the wind, right? So next frame it goes here. Next frame it like halves the difference again. Next frame it like halves the difference again. This will give us like a bit of smoothness in transitioning when the wind changes, but it will be relatively snappy and all the particles will kind of do it at the same time. So I think I'm going to do... Basically what I want to do is like find the average of these two vectors each frame. And then... okay, let's do this a nicer way actually. So I'm equal to vector dot... Yeah, it is. Yeah, the set method. So yeah, the issue is that basically I changed it so that anytime a particle goes off the screen, it will respawn in a random position and its velocity will be exactly equal to the wind speed. Which meant that as the old particles died out and were replaced, it would begin to like match the current wind speed, but it just kind of looked weird because it took some time for that transition to happen. What I'm thinking of doing now is just saying set the velocity to the average of the current velocity and the wind. So add velocity and wind together and then divide by 2, which should kind of average these things out, and I think will work in a bit more snappy way. Is there no wind, or I think we're just getting some really slow wind randomly, maybe. I can't tell if this is working and my wind's just weird or something else. Okay, I think I just want to scale this up. By some factor, like if we do 10. Yeah, the set method, okay, this is really fast, but hopefully it gives us a sense of what's happening. So, do that. Okay, that's kind of fast still. Yeah, so we can make that happen more slowly. I'm just fiddling now, by the way. Like, this is something you just want it to feel right, so you just need to fiddle around with these parameters, but maybe this is not the most productive use of my time, but I can never resist doing this stuff. Is there like a... Ooh. Okay, this is exactly what I want. So, lerping means interpolating, linearly interpolating between two vectors, right? So if you have V and W, to do a 50% lerp is basically to say what's like the halfway point between them. That's going to be our 50% lerp, or 75% lerp is going to be like here. 25% lerp is like here. So what I was doing by averaging them was like a 50% lerp, but by putting that value down, I can make the transition more gradual. So we're going to lerp from the velocity to some factor times the wind speed. That was too fast. So now, rather than like 0.5, let's go 0.05. So actually a way slower transition, but it's still going to be pretty quick. I expect, anyway. Unless this is not working exactly how I expected, I should probably ever check that. P vector. Where are you, lerp? Oh, I didn't assign this to anything. There we go. Schoolboy error. Okay. See how this looks. Okay. So it takes like a second or so to more or less transition. Still not the prettiest thing. I think, what did worms do? They had like leaves floating or something. You know what? This will do. This will do right now. At least, you know, it's not the prettiest thing. It tends to leave gaps, like, as the wind's moving to the right, it tends to leave gaps over on the left. Really, I'd probably want the wind to spawn, like, in the opposite side to, One way to do that, actually, would be to wrap the wind around, so rather than respawning randomly, if it goes off the right-hand side, it respawns back on the left. Let's do that. I think that may actually be way nicer. So, it's going to say if x is less than 0, then I'm going to say, I'm just going to add world width to sort of respawn it over on the right. Not x is world width. I was debating to like put this on one line or not. I'm never sure where the line is, no pun intended, between putting stuff on multiple lines versus having it really long form. So this will change to y. Okay. I think this seems reasonable. Yeah, at least they're more like uniformly spread across the screen right now. Okay, here's a question. Do we like that the wind can blow in any direction, including straight down, or should we just have the wind go left and right to various different strengths? What do we think? Because gameplay-wise, I'm not sure how to like compensate for this like downwards wind, right? It seems kind of hard to account for. Okay, seems to be okay though. Horizontal, yeah. Horizontal-ish. Okay. So we could do like, I like horizontal-ish actually. So let's do something like p vector with a random from minus max wind speed. Yeah, okay, we can do that. So let's go from minus max wind speed, so sort of to the left. So I realize I'm typing with loads of random other code here. So this is going to be our x. Let's just do this separately. And let's make y like something way smaller. Like just up to 1/10 of the variation in y, maybe. Okay, technically this is no longer the max wind speed, because if we're going all the way right and slightly up, it's like not quite that, but I'm okay with this. Okay. I feel like this seems a bit nicer. Okay, wind's going off over there. Still going that way. Yeah, I like that there's a kind of slight variation. That's a bit of variety. Yeah, okay, this feels more like it. Yeah. Okay. Awesome. It's kind of weird because this still looks like space to me, so it actually feels like we're just spinning around in space and on an asteroid or something, and the whole thing's now started rotating in the other direction or something, but I'm kind of cool with it. Okay. So, what's next? I think there are a couple of things we could do next. Yeah. Did you ever play Unreal Tournament? So there was a map called CTF Space, I believe. Kind of reminds me of this. It was on like a floating asteroid with like a star field. Not Quake, it was Unreal Tournament. Not CTF Space, CTF Face. Facing World, yeah, this one. It very much reminds me of this. Super nostalgic. This is one of the all-time classic like FPS maps. Not sure if you can really see that. Like you had these two towers and these like you were on this asteroid with stuff flying around you, and you had like this trail which you had to kind of run through down the middle. It was super fun. Okay, so there's a few things we can do. Wow, look at all this crap we've drawn. Let's clear this off. So there are a few things we can do. So we've got... wrong size. So we could do like an off-screen indicator, by which I mean if our projectile's gone off the top, it would be nice to have a little arrow which like indicated where it was still, because sometimes it's hard to tell if the projectile's like gone all the way off over the top and off the other side. So it'd be nice to have an indicator. Hey critics, thanks so much for tuning in. Did you ever play a game like this in your childhood? If so, what was it called? Wow, unfortunate shot there with the wind. Yeah, so having an indicator which shows when it's off the screen, that's one thing. Another thing we could do is like health or lives, like how many times you can be hit. Worms, yeah. I feel like worms, this was kind of... history lesson time. Yeah, I mean, I played Worms more than this actually. Yeah, so Scorched Earth was 91. Worms 1 was 95. Yeah, so I feel like this was a few years ahead of Worms. It was a more simple version than, you know, Worms had the nice text graphics and stuff like that, but this was a kind of simpler version of the same thing. I feel like there were versions of this in the 80s at least. It's going to be hard to Google. It's going to be hard to Google. Yeah, I kind of raised on Worms as well. Worms 2, Worms Armageddon, the best of all. Okay, yeah. So we could have of our off-screen indicator. We could have some sense of the tanks having health and lives. We could add projectile types. Right, so we could have like a cluster bomb, like very Worms inspired. Neon grenade. Grenade would be interesting. The sheep, right? The concrete donkey. They were so creative, all the Worms weapons. So yeah. Any votes, any suggestions on which we should attempt first here? Spelling health would be kind of nice. feel like projectile types are more fun. Like having the health and lives are kind of needed for this to be an actual real playable game, and this is more of a quality of life feature because it does get annoying when you can't see that. You vote for fun. Okay. Cluster bomb. Cluster bomb in it. Different kinds of terrain, yeah. You could do that. I think the way you would do it is you'd have... So right now we just have like this green terrain. And when when the explosion comes, it just like wipes it out. I guess you could have like a different color terrain so that when the explosion comes, like if an explosion happened right in the middle, it would kind of remove the green, but just like downgrade the blue to a green. Kind of like that, and then the next time it would like wipe out the green. That's kind of interesting, actually. I don't know how you would use it to your advantage, or how it would factor into the gameplay, though. I think you could do something like that. Yeah, you just have like a hierarchy or like a tier list of terrains or something like that. You could also track health for each pixel, but that's getting really... seems like a lot of work. So... no, the tanks can't move right now. There were versions of this where you could move left and right a bit, but as it is, you're just like a turret. Okay, I think I may start with the off-screen indicator because I can do it really quickly, and then we'll move on to cluster bomb and maybe a grenade because it means refactoring some of my code, because if we have a cluster bomb, right now there's only ever one projectile and explosion in the game at a time, so we need to have a more advanced thing there to do cluster bombs. To do grenade, we would need to have some physics for if it hits the ground, how it would bounce off the ground, which is kind of hard because, you know, the ground's actually pixelated, so, you know, it's like the ground is kind of technically always like this, so, you know, if your grenade comes in here, then is it just going to bounce like straight back off that way, or should we kind of try and account for the general like slope of the terrain here? And, you know, you could get really fancy with trying to like smooth out the terrain and have the bouncing projectiles account for that in a sensible way. Defenses. That could be interesting. Like you could spend a turn to like drop a shell around yourself or something. That's your little tank. You would have a bubble you could deploy or something. Could be kind of fun. Okay, I think I'll do the indicator, yeah, just because it is so quickly. Can be done so quickly. I think I will say if... At this point, I should probably have a switch statement. Power. So if we are resolving, I think we can do this real quick actually. If we're resolving, I'm going to say if, you know, affected projectile is not null, and active projectile dot, and the projectile is not dead, and active projectile's position y is less than 0, meaning off the top of the screen, and given the coordinate system of processing, then we can draw this indicator. What should we draw? I feel like we can get away with just having, if our screen's like this, maybe just like a little arrow. So, you know, maybe our projectile's all the way up here, but just any time it's just based on its position, right? So if it's here, get a little arrow like that. I think worms would even have like, you know, a little number showing how far away it is, but we don't need to get that fancy. I think just having the arrow is going to help. So You don't want to fill this thing with anything. Let's give it a red fill. Feels appropriate for some reason. Then all we need to do is draw this shape. So processing lets us do a begin and end shape, and then just specify vertices in the middle. So, and we know that there are going to be 3 vertices. The first one is going to be x is equal to our projectile's x. Now this vertex here, let's call this 0, 1, and 2. So that's completely unreadable. But this is going to have an x coordinate equal to the projectile's x coordinate, and its y coordinate is just going to be 0. And then these two are just going to be like offset somewhat arbitrarily to form like an arrow shape from that. So let's start with active projectile pos.x, and the y is going to be 0. And then we want one, if we're sort of going clockwise, it's going to be slightly to the right. Yeah, very arbitrary. And then slightly down, and then the other one, same but off to the left. Is that it? I think that may do it. Let's test this bad boy out. Huh. Awesome. Yeah, it's now way easier to tell than that's when that's gone off screen, right? If I try and do an actual reasonable shot, it's going to be quite hard. Okay. That seemed to work, no problem. We can call that done. Somebody said fun stuff, so let's have a go at a cluster bomb. I don't know why I'm writing a to-do list in this form in the middle of my little whiteboard image. This is not the most organized thing I've ever done. It's a horrible, horrible text editor. Okay, let's take a shot at this cluster bomb. So there are a few things we need to account for. One is that now there may be multiple projectiles which exist at any one time, so our whole active projectile thing doesn't really work anymore. This now needs to be something like a list of projectiles. Import list, because for some reason it's not imported by default. So okay, there's our list. Same for explosions. We now probably need to account for having multiple of these. Actually, let's make this a linked list, because we can remove dead things from the list regardless of their position in the list a bit more easily. So okay, we have a linked list of those. Same thing, I think, for explosions. And now we should see a load of errors where we refer to them, and this will guide us in what we need to fix, I think. So let's do something like so we do this thing here to kind of check if anything still needs to be resolved, and then we do all of this stuff. It is going to now need to be like looping over these lists, but one thing I want to keep track of is if we're done resolving, and we're going to assume that's true to begin with, and then as we loop over these, if we find something that needs to be updated and it's not dead, then we're going to flag this as false, right? So I can do something like just loop over these projectiles. I'm going to say p dot update, and then I'm going to say if. I'm going to say if. No, indecisive. I'm going to say if p dot is not dead, then nope, equals false. Okay, we do a very similar thing for explosions, I think. Now, what I was going to do here is say if it's dead, I'm going to remove it from the list. But I think instead what I'll do is I'll let everything stay in these lists, and then at the end of each turn I'll just clear the list out. It's going to be way easier than having to iterate over and remove things from these lists at runtime. We don't have to do that, so why make it more complicated for ourselves? But I think I'll probably change this to something like is dead. I'm going to update it. A bit more like this. Okay, and now I can simply say if we are done resolving. You know, maybe a nicer thing to say would be to say, you know, something is alive. It's a bit more intuitive maybe about what this means. I don't know, I always agonize over naming too much. So if there's nothing still alive, then we can clear up. So I can actually just do dot clear or dot empty or dot clear. Nice. Yeah, this seems a way nicer, relatively clean way of doing things. So we do this. So I also want to loop over these things when I draw them in a very similar fashion. Okay. Ah, so I need to do this for each projectile now, this whole drawing thing. And in fact, I'm again doubting the way I've done this, and I would probably actually prefer to do like this. I just like this pattern more. Sorry, I'm being very indecisive about how I want to refactor this stuff. Yeah, I prefer to just bail out of a loop with continue rather than nesting stuff inside ifs, if I can avoid it. In this case, I'll just do the same thing for consistency. It's kind of redundant. I think these are already probably... No, they don't. Okay, I was going to say they might already check that. Now, what I want to do here is loop over every projectile. If it's dead, then I'm not going to do anything with it, but if p.pos.y is above the screen, and then we're going to do this with p. Okay. Now I could have put this in the rendering code for the projectile itself, Maybe I should have done. Why didn't I? I don't know. It feels like a UI thing rather than a projectile thing itself. I don't know. There's probably a couple more errors. Most likely we can't do this anymore. We just need to do active explosions.add new explosion. And there's probably somewhere else, probably where we launch the projectile. We have to do active projectiles.add. Okay. So if we've done this correctly, everything should still function exactly the same. Hey Tobot, thanks so much for the follow. Thanks for joining the stream. Or it's just going to crash and throw us an error. Okay, looks okay. Let's check that everything is working. Yeah, that's a lot of code to change without anything going wrong. Look at these custom emojis. I didn't know if this was a Twitch thing I wasn't aware of, but awesome. I can't quite see what that is. Oh, it's a cat. I approve. Okay, I mean, I feel like this is working just fine now. Seems to be okay. Creativity, we'll call it. You know, don't put yourself down. Yeah, creativity. Awesome. Okay, that seems to be working. So now, yeah, we're doing good. We're doing good, thank you. We're just working on implementing worm-style cluster bombs into this. Not sure if you ever played that, but I think that could be fun. Okay. The way that works is normally you launch it, and then if you press space again, it will like split up into a cluster. So I think what I'll do is, so there's a couple of ways I could do this, right? I could have subclasses of projectile, like a regular projectile and a cluster projectile. I think probably what I'll actually do is just have like a type enum or something like that. Projectile type, and we're going to have regular. Do I do this? Do I subclass? Okay, let's subclass it. Let's add a new thing called cluster bomb. Like this. We then need to give it a appropriate constructor. I mean the same constructor basically. Yeah, I thought better of, I feel like an enum is the old school way and just having some switch statements inside the projectile, but yes, it's probably nicer. I think it may need another property, which is probably like, and I'll make these sort of constant. In processing, can't do proper constants inside classes because of the way it works, but let's do like a child count. So how many fragments? Let's say 5. And then what we kind of want to do is have this thing fly through the air. Then when you set it off, it's going to split into, I guess, 5 separate things like this. So we can either have that be done randomly or in some systematic way, like in terms of the initial velocities of all these sub projectiles, right? So we could just give them a random velocity, or we could say, you know, if our projectile spawns here, we kind of want our cluster bombs to be like one going this way, this way, this way. If there are 5, right? Like maybe it's some kind of thing like this. So I think what I'll do is define like a spread, sort of like this, and then based on the number of children, it's going to evenly space them out throughout this spread. So you get like a neat spreading cluster, something like that. So let's do spread angle is going to be equal to I don't know, pi by 2.5. If I'm thinking of this in terms of like the half angle, if you like, so it should give us 45 degrees, I think. So how do we connect this logic up? So I think one thing we want to do is something like on no, it doesn't have point to collide, is it? Like on secondary input, let's call it. So, and the regular projectile is going to do nothing because it has no special behavior. But then we can do something like overriding it here, right? We can spawn our children. So, and then what I want to do is if we are in the resolving state, what do we call it, state.resolve, then what I'm going to do is go through every active projectile, skip the dead ones, and then I'm going to trigger the secondary input here. So this gives these projectiles a way to know that something's happened. So I think what I'll do is, okay, for now let's just do a print line, and when we launch a projectile, let us instead create a cluster bomb. So this should behave exactly the same, except if we press space when it's in the air, we should see boom printed out down the bottom. So wait for it to come back into view, don't know why. Okay, I can trigger that multiple times, but that's really not an issue because we can have something happen like so we want our main projectile to die, and then what we're going to do is say for 0 is less than child count, so we're going to iterate child count times, and then we're going to spawn a child, and we need to figure out what its velocity is going to be, so that's where this deal comes in. So okay, we know that this is 0, an angle of 0. Awesome, thanks Paglasio, always appreciate you tuning in and having your contribution. Hopefully, yeah, if this inspires you to do anything, please share it with us. I'll be very interested to see, and have a good rest of your night. Okay, so we already figured out that this is minus pi over 2 degrees. So basically we want to go from minus pi over 2 minus this spread amount, which will give us, you know, like this angle, and minus pi over 2 plus this spread amount. So that gives us our sort of lower and upper bound. Then we just need to divide this into a number of sections based on the number of based on the number of children. So if there's only one child, we actually kind of want the middle section. If there are two, we kind of want... I think I was going to go with an even spread, right? So if we have one child, then we want it to go here. If we have two children, then we want it to go like this, and so on. If we have three, then I guess we want it to go like this. So I think what this basically means is if there's one child, we divide this into like two sections. If there are two children, we divide it into three sections. So kind of do like a divided by n plus 1. And then, okay. So let's say the start angle is going to be equal to minus pi over 2 minus spread angle. Let's say the angle step. So we know that the total... Oh, actually, will this work? Yeah, this will work. Okay. So we know this total angle here is spread angle times 2. So we divide that by number of children plus 1. So if it's one child, then it's spread angle times 2 divided by 2, which is spread angle, which is this section. Okay, I think that works for us. Sorry, I feel like I'm not explaining this super clearly. So angle times 2. So the angle step is total spread divided by child count plus 1. Then what we can do is the angle which this one spawns at is going to be the start angle plus I plus 1 times the angle step. I think this should work. Let's set the child speed. Did we have a maximum speed somewhere? That was 200, so maybe these should be a little bit slower. I don't know. Let's say 125. Actually, probably way slower, right? We can fiddle with this. Okay, so launch direction is equal to from angle the angle. Let's call this launch angle. It's not an F vector. That's Unreal Engine I've been working with. Okay. So that should give us the direction, and then the launch velocity is just launch direction dot multiplied by launch speed. So we called it child speed. And then I think we can just say active projectiles dot add new, this time a regular projectile with basically, okay, so I almost just put position in here, but we don't want our children to hold on a reference to the same position vector as we've got. We want them to actually get a copy. So can I copy a vector like that? Okay. Will this work? I think this may work. If I had enough brackets. So hopefully now I should be able to launch my cluster bomb. And excellent. Okay, crash the game. Okay, that's fine. Okay, the issue is that we're looping through all these projectiles, and then when the secondary input happens, we're actually adding stuff to this same list as we're iterating through it, which is no bueno. So you can't really do that. I'm going to make these array list again because I no longer need to remove stuff as we're going through them. And what I'm going to do, which is unfortunate that we need to do this, but sometimes it happens, is we need to create a copy of this list just to then iterate through it. Yeah, they are. So they're spawning into the same list as everything else, and they literally act just like regular projectiles afterwards. Yeah, the issue being we're iterating through the list while we're trying to add stuff to that same list. And there are ways to do that, but easy way around that is to just effectively create a copy of the list for us to iterate over, and then this will add stuff to like the real list. There may be other cases with other, if we had projectiles which would spawn other projectiles in their update function, we'd maybe have to also do this elsewhere, but I think that's fine. Another approach would be to have like a queue of newly spawned projectiles as a separate list and manage that separately and fold those into the main list at the end of each frame or something, but I think we're okay doing this for now. Okay, please don't crash on me this time. Awesome. Oh, wrong direction. Yeah, the little indicators are working as well for multiple projectiles. Awesome. This is pretty cool. I think one issue we may have is the child projectiles are just as powerful as the parent. Like they should be smaller, right? They should each be smaller. So let's think about how we do that exactly. One thing it probably means the explosion radius needs to be a separate thing here. Should probably pass that through as a parameter. Then we can pass it through here. Which means that when... Is it not a tank which spawns something? Yeah, this is not the best. You know what, we can say... Start with 20. We can have a child radius. We can have our own explosion radius here. So I can pass hours in when we get spawned. I can pass the child exploding radius in when they get spawned, which should probably be we can't do that. Okay. I want const. Okay. Let's just make it part of the constructor then. And then actually let's say is equal to our explosion radius divided by child count. Seems reasonable. Maybe, you know, technically speaking, if we've got a radius and then we spawn 2 with half the radius, that's actually less area. So we should probably do something with like the square root to make the area preserved, but I feel like another factor is that when we have the terrain, so I feel like this tangent is maybe not interesting to people, but okay, we have our explosion. What's interesting in terms of gameplay, I think, is like the coverage horizontally over the terrain that an explosion gives you. Like that's maybe the key factor. So even though an explosion that's like half the size is only like a quarter of the area, it still covers half the terrain width, which is probably the important thing in terms of hitting the opponent. So maybe just dividing this is fair. We shall see. Hey Top Hat, thanks so much for tuning in. Not sure how long you've been hanging around, but we're working on this tank clone, and the last thing we just implemented is this little cluster bomb, which I should now be able to demonstrate in full effect. Wow, those are tiny. Is that too small? I don't know. Maybe fewer children, maybe a different factor. Interesting. You know, we could just say I don't know. We can just code this in so we can tweak this manually. Maybe trying to calculate it based on the number of children is not actually ideal. We should just tweak these numbers as good gameplay designers ourselves. Yeah, so we are using processing, which is actually based on top of Java. So it's basically a framework or a library for Java, and it comes with its own little app, which makes it a little bit easier to very, very quickly get stuff up and running. And it's designed specifically for making it very quick and direct to draw things. So, okay, there's a lot of code here. This may be confusing jumping in, but it allows us to kind of set colors and then just draw shapes very easily, load and draw images and play sounds and stuff like that. It's very good for small projects, which are interactive games or graphical things. I would say it's perfect for those kind of things. It's not really suitable for like a big project, but little prototypes, little one-off things, it's my go-to thing for anything like that. Okay, that seems kind of reasonable to me. A little indicator on the top, if I spread that apart. Okay, this feels very Wormsy. This feels pretty good to me. Yeah, this is all done in code. So the terrain we generate with some Perlin noise. The tanks are just little rounded off rectangles, you know, with a little turret there. And then the background, which is very confusing what it's actually supposed to represent, is just some little dots moving around. So it's all done. The terrain is generated and then everything is drawn in code. Suds, what other technologies have I used to write games in? So I have used I've used a lot of things, like over the years, like many different things, but like these days I use a bit of Unity. I can quickly show you a project we did on an earlier stream with Unity. I feel like I've shown this several times now in different streams. So here we go. This thing we did was like a fancy kind of card effect inspired by Hearthstone. So you see the like shiny dynamic reflections and these sort of heat haze animation on the cards. So I use Unity for this since I wanted to do some like 3D graphicsy stuff, which processing is not super ideal for if you want to make shaders and stuff like that. So that was Unity. I also do a bit of stuff professionally with Unreal, which I can't talk specifically about what that is, but that's some project I'm working on which uses Unreal Engine. Yeah, aside from that, I've played around with Pygame in Python and processing in Java. I've done some basic like OpenGL Java stuff as well, so lots of different things. Right tool for the right job, pretty much. But I would say I use processing if I can, if it's small. If not, I would probably then jump to Unity if I wanted to, like, you know, make a scene and do more 3D stuff. Unreal is cool, but it's a bit more, I feel like it's a bit more heavyweight. It suits certain kinds of games more than others, and it's got more of a learning curve. Godot. I have heard of Godot. I know a few people who use it. Is the language in Godot, like, does it use JavaScript or like a Python type language? I think it looks really interesting. I mean, if I didn't already have processing in Unity, I would probably have used something like Godot. Yeah, I hear really good things about it. Check our little to-do list quickly. So, safely say we've made that cluster bomb work. Yeah, like a Python type thing. Yeah, that's cool. So, let's think about one more thing, which is kind of like actually selecting the bullet type, I suppose. So I think what I may do is, so right now we're kind of hard coding just for testing the type of thing we spawn. Actually, I think we need to do that in a bit more of a sensible way, which to me means probably, okay. We want to wait to let the players cycle through these. And then when we launch the thing, I think we're going to need to maybe change how this works. So I think rather than having this actually launch the projectile, I'm just going to have it give us, because really we need it to calculate the position and velocity of the launch, but we don't need it to actually construct the object, and it's a bit weird for that to happen in here. I suppose I could pass the projectile type. I'm torn here. You know what? That's going to be the easiest. Let's call it projectile type. And I don't super like this, but and then all I'm going to do is switch on that. Yeah, how do you find Godot? What kind of stuff are you using it for? Kind of curious to know. So we had a regular. It's regular. We're going to return a new regular projectile. If it's a cluster bomb, return a new cluster bomb. Let's actually make this a bit, tweak this slightly. Yeah. So ultimately, somewhere we're going to need this sort of table. This isn't the place that it should be, I don't think, but, you know, I'm gonna allow it to live here for now, because, you know, the project has a known limited scope, and I'm making excuses for why I'm not architecting my code cleanly, because I'm lazy. Yeah, that's great. Yeah, absolutely. I feel like, yeah, Unity and especially Unreal Engine are way, they're like processor hogs, right? They're way more heavyweight than, definitely Unreal is, yeah, they're definitely kind of, heavier than they need to be, which can be annoying if you're trying to make a really simple game that should, you know, some of the games you work on as like indie devs are games like from the 80s or 90s level of technology, right? So they should be able to run 1,000 frames per second on a modern machine, but you try and do it in like Unreal Engine and it doesn't quite work out like that way. So I actually feel the need for like lightweight stuff. I think that's great. This should never happen, so let's just say. Okay. I'm also thinking these don't need to map one-to-one, right? Like you could have a big bomb, which is also a projectile, but just has a bigger radius or something, right? So these don't necessarily correlate exactly. Okay, so we have selected projectile type. So, I mean, I'm assuming this will work for us. Nope. So that's what you're going to launch, and you're going to launch the selected projectile type. So this should give us a regular projectile. If I hammer space, it's not cluster bombing. Whereas if I change this to cluster bomb here, then hopefully that gives us a cluster bomb. Yep, seems okay. One thing that's kind of weird about the physics is that the little clusters always come out at exactly the same speed. What we should probably do is add the original projectile speed onto it. That's probably a bit more accurate. So we're going to take this and we're going to add velocity onto it, add our own velocity. So they will inherit their parent speed plus the like spread angle deal we've got going on. Which means that now if I launch it like really fast to the right and then cluster it out, they will move in a slightly more realistic fashion. Okay. It does, yeah. So if I launch this straight up, I mean, hopefully we'll see something there. Or if I launch this one straight up, then it's going to get blown way over. Yeah, I mean, that's a key element, right? Because otherwise you can just very quickly hone in on the target's position. I think having to adapt for the wind, especially since your turret stays at the same angle, you can just gradually adjust, which kind of takes away some of the fun. So having to account for the wind, I think, is a key, or maybe the like key skill element in this games. Don't get into a duel with me. Check out that pinpoint precision. Okay. Okay, so we need to be able to cycle through these and kind of display what's selected, right? So where do we draw UI? So let's say so let us draw some text, and it's going to be selected projectile type dot costume name. Probably need to move this down. Okay. Almost there. Let's just move it across and down slightly. Bit more. One more pixel because I'm very anal about these things. Okay, cool. So now we can see our active projectile type just fine. I don't know if you've ever used enums in Java, but they're actually pretty interesting and kind of powerful. Like, they can have properties, so we can actually do stuff like, I forget the exact syntax here. This right? Something like this. Yeah, so you can kind of give them properties and a constructor, which then allows me to associate like a friendly name with each of them, and then when I draw them in the UI. Also, Top Hat, thanks very much for the follow. Instead of just getting the raw underlying name, we can get the nice friendly label. You know, we could also pack other stuff. We could even have the spawning function for the projectiles, like, embedded in this enum, which might be kind of nice, but for now I think we'll just do it this way. So now we should get the friendly labels. I almost went to do what I planned to implement next, which is to press tab to like cycle through the projectile types. So let's do that. I'm going to say if state is name and it should be here actually, and it should be if tab. Okay, then cycle to the selected projectile type. So this is kind of annoying, but I kind of wanted to use modulus to do this, right? The same as we do for the active player index. So we have players 1 and 0 and 1, and we have an active index which starts at 0, and then we increment to 1, and then we increment again, but use modulus to like wrap back round, so it effectively alternates between 0 and 1. And for our projectile type enum, we want to do the same, but they are, it's just like, what do we call it, like regular and cluster. So these do have numeric values associated with them, but kind of indirectly. So I think we need to do something like this. Is equal to dot ordinal something like this, right? So we can use this ordinal thing to get the numeric equivalent of an enum, and then we can use, how do we count them? Values.length. Yeah, this is not super ideal, right? Well, this is the equivalent thing of kind of cycling through these and using modulus. And then I can say something like this. So this is kind of ugly and kind of hacky. I could have just put them all in a list or something, but this I believe should work. Or not. Let's debug this quickly. Had some old breakpoints in here. So if I press tab, interesting. Doesn't seem to send me the tab input as I would like. Arrow keys, Alt, Control, and Shift. Okay. Ah, okay. So in fact, this should be done like this. We'll put this down here for now. Okay, this is probably a literal like tab character, so I can probably do like that. It's probably equivalent. Let's label this. Sounds very fancy. Okay. Hoping that will correct that for us. Yeah, I'm not a big fan of how processing handles like detecting keys being pressed and coded keys versus which are like arrows and shift and stuff versus other keys which are represented by their actual ASCII characters. Not a huge fan. Probably an issue with brackets there, I would imagine. Yeah, there we go. So now I can launch a regular projectile. Top Hat, thanks very much for dropping in. We do these same time every week pretty much. There's some other streams on the channel if you fancy, you know, if you see a notification and are interested. There's some other stuff we get up to, but it's great to see you here. Good luck with Godot. Yeah, drop back anytime you feel like. So we now have our regular and cluster working. I can fling these things out. Yeah, this feels pretty reasonable. I think maybe the last thing I will do perhaps is have some kind of win condition. I feel like that's the last thing we need to make this an actual playable game. And already the choice between cluster and regular is maybe enough for there to be some gameplay nuance at least. Some strategic element. Okay. So I think the way we'll do this is up here. So they have a health of 100 to begin with. Let's actually make this like 3, shall we say? So I think what we'll do is when an explosion happens, is we will check to see if we hit a tank. And what I'll do is just give this like a little on hit function. Say if health is greater than 0, we're going to reduce our health. I have a rule about not having single line ifs like that, so I won't do it. Okay. Then an explosion, what I'm going to do is say something like and I'm going to say if t.pos.x, if the rounded x position, I think it should be an integer anyway, right? Pretty sure it is an integer, but we store it in a vector, so technically it might not be. And just check for an exact match. Basically, if we explode the exact pixel that we consider the tank to be on, then we will deal it some damage. So sort of glancing blows won't quite get it. T dot on hit. Then I think what I will do is we can draw some other UI stuff up here. So let's draw tank's health. How to do this? Okay, let's just draw one first. So we're going to draw tanks 0.health at width 11. The one issue is we want to change the alignment of the text so it's like right aligned. I'm going to put this sort of down the right hand side of the screen, so I hope there is a text align function, which there is. Text align right, okay. Which means when we draw this stuff, we should be sure to align it left. Because doing right up here will carry forward to subsequent stuff, so don't want to have that mistake. And let's do it at okay. Let's try and blow ourselves up. See if this number goes down. Okay. Seems reasonable. See if I can land a shot here. almost. Go the other way. Okay, that looked like that worked anyway, so what I think I will do now is no. So tank T in tanks. Just going to do this. Then so right now their healths are going to be drawn on top of each other, so I just need a little offset like this. This equals 11 again. So each time through the loop we'll kind of step down and draw these things one after the other. Okay, let's have a little bit more spacing. Let's actually do a bit of a nicer label. Let's actually move it left slightly. I don't know. This does not matter in the slightest. Let's not call it health, let's call it lives, because that feels more old school. And I'm very indecisive. Okay, that counted since it barely clipped. The actual pixel that gets counted is the middle of the base. So we could try and do something more fancy, and any explosion in the general area could harm it, or even the amount of health could be based on the distance from the explosion or the strength of the explosion or something, but that's maybe overcomplicating things. Let's try and land a sweet regular shot. Okay, my aim's not so good today. We'll go for cluster instead. Okay. That's that. So the last thing to do really is to have a game over state. And I think what I will do is, where are our states? So we have game over. And what I want to do is, if it is game over, game over message. I'm going to say if not the nicest way to do this. Also, it doesn't account for multiple tanks, even though all the rest of the code is totally agnostic and supports having many more tanks. Okay, we could do this in a fancier way. I don't need to hardcode 2 tanks here. Okay, we can be more clever than this. Okay, let's do something like for is draw is equal to true to begin with. Oh, actually, okay, let's do tank. Or, winner index equals -1. So I equals 0. Basically, I'm going to have to compare the healths of the tanks. If they both have 0, which probably won't happen, but maybe if you did some crazy cluster bomb thing, maybe that's possible, then it's going to be a draw. Otherwise, there should be only one tank with any health left, and they're the winner. So I can just need to find out what their index is and then display a message that kind of refers to them. I'm going to say if tanks I.health is greater than 0, then index is equal to I. We could break then. And now we can say equals player. So what we want to get is a label for each tank. So I think all we need to do is say win index +1. So if tank 0, we'll call them player 1, just because for some reason game players don't like to start their counting from 0. Don't know what's wrong with them. So there's two cases, right? So if winner index is equal to -1, then it is a draw. Otherwise, it's this. This is a bit an ugly ternary. Okay, let's just do this long ways. Don't know why I'm putting this so compact. Okay, then we can do text align. I think we can do something like center to center it both horizontally and vertically. Let's do no stroke. Let's do fill white, and then let's do text. Let's put our game over message at mod width times 5 and world height times 0.5. Wow, I couldn't find the asterisk key there. Yeah, right, slap bang in the middle of the screen, like so. What happens then is this should probably work okay, but we need to somehow detect that a win has happened, right? So check for win. We can do this simply with int alive tank count to 0. So for tank t of tanks, say if t.health is greater than 0, then alive tank count can be increased. And I can say if live tank is equal to 0 or 1, then it's either a win or a draw. Then we can do what do we call it? Game over. Otherwise, we can do this. Okay. So Let's try and get this to happen just by spamming some bullets at myself. Player 2 wins. Seems to be just fine. And then last thing is let's allow the players to press space to start a new game. Let's do this times 0.4. Should be fine. And then if we're down here, obviously all this state code just in branches, ifs like this is not ideal, but there's no answer to that, but it's just, I just shouldn't do this, but I have anyway. Okay, so if this happens, we need to reset the game. How do we do this? Let's just put the initialization into a function somewhere. Like here. So just all of this stuff. Go in here. There's other stuff I think which also needs to change, like active tank indexes should be 0. Let's also reset the selected projectile type because it will be equal to this. So I should just make it a regular. Do we call it regular or normal? Okay. Okay. Also, so there's the thing where we clear out all of the projectiles. We probably want to do that regardless. If somebody's won or not. And let's make sure that we bit of a redundant comment there, but works for me still. Okay. So regular cluster bomb. Let's make an attempt. Way off. There's probably something I forgot to reset properly. We can kind of account for that later when something looks weird or crashes. It's very satisfying seeing the cluster bombs all hit the ground separately. Yeah, that kind of ripple effect of the explosions. Okay. And I feel like cluster bomb may be a little OP, but ooh, interesting. Okay, no, that's probably just a bit of terrain. That's probably legit. Not a glitch. I thought like a particle was hanging around or something, but I think it's legit. Come on. Play 2 ends, press space to restart. Ah, okay. It worked, but the terrain is exactly the same. So what we actually need to do is reseed the noise. So is there like a noise seed? Yes, it does let us do that. So let us noise seed with just the exact time, shall we say? I think that should cover that for us. So it's going to kind of suicide again here. That wind is going to catch me out, I think, and blow these right back. Or not. Okay. We could debate about whether friendly fire should be a thing, or even whether you should be able to be damaged multiple times per turn by different clusters and stuff like that. Okay, favourable wind. Close. That could be a little hacky strat, right? If you launch the projectiles in and then you burst apart all of the cluster things right next to them, then they get hit multiple times and you just win. So maybe a slight oversight there, but I think not a huge issue for a little prototype game. Yeah, right, we got hit multiple times there, which is maybe not ideal, but at least we can check the logic. The terrain looks pretty cool though, nice and torn up, very wormsy. Let's press space and fingers crossed we get a different terrain. Yeah. Oh. We should probably also reset the state. So that we can actually play again. Okay, I think we're pretty much there. I think this will be the last little test game, and then I'll probably call the stream a wrap. It's been about 2 hours, which seems to work out relatively well. Can I just scrape this through? Close. I feel like this is, yeah, pretty much fully playable right now. The wind feels like a reasonable amount of variation as well to have to account for. Oh, this is going to be hard. Yeah, I'm sure we can tweak the cluster parameters as well to be a little bit more gameplay-wise what we're looking for. Ah, come on. I just have to start tearing through some of this terrain. Yeah, not gonna lie, I'm kind of zoned into this now. First blood. Yeah, like the velocity of the clusters feel a bit off. I mean, it's... Oh, crap. It's kind of physically correct. They just get the relative velocity plus, you know, they launch in that regular pattern. But just gameplay-wise, it's not quite what I want. I would have to look at... play a bit of Worms or something and see how it feels. And try and figure out how they've tuned all the parameters and stuff. Another thing which might be nice is if we totally undercut some terrain to have it fall down. Now, there's things we did in other streams, like our falling sand thing, which I'll just pull up, which we could repurpose to actually make that happen, but might just get weird if your tank gets buried or something like that. I don't know how we should handle that. Yeah, the bump up always pushes them forwards, where you actually want some of them to kind of go a bit more further backwards, so it could definitely be tweaked. Okay. You can use it to adjust for a slightly incorrect shot. Okay, must be it. Player 1 wins. We're supposed to restart. There we go. We have completed, I believe, our Scorched Earth, aka tank clone. All the basics in there. We got the wind, we got the Perlin noise terrain, we got the destructible explosions, we've got cluster bombs. Yeah, this is pretty good. I mean, this is almost exactly like some versions of this I played back in the day. I guess in the early 90s it must have been. I mean, I was born in the late 80s, so it can't... Yeah, I couldn't have played this when I was like 3 or 4 years old, so it must have been the 90s. Yeah, I think we will call it there. Thanks so much everyone for tuning in. If you want to follow what we do here, we can check out our Twitter, where I regularly run polls about what we should do on the next stream. So normally on a Wednesday I'll put this poll out. Yeah, something we did a couple of weeks ago. I'll put a poll out and people can vote on the topic for the next thing. Otherwise we have a Discord community which is a great place to suggest different projects and also look into our main deal, which is Steamhounds, which is the kind of actual main kind of commercial game we're working on. There it is. There's some nice promotional artwork there. Yeah, I'm pretty pleased with what we achieved today. Wrap this up in about 4.5, 5 hours with both streams in total, and it pretty much does what I hoped it would do. And it feels right? It definitely has the feeling of what those old games were like. I'm now rambling, so I will actually wrap it up this time. Thanks everyone for tuning in, and I will catch you next time. Bye bye.